not so sure it's on Facebook, but if they are, welcome to the Royal Astronomical Society of Canada, Winnipeg Centre's monthly meeting. And I'll just open with a land acknowledgement. The lands from which our members and guests are joining us are located on the original lands of Anishinaabe, Cree, Ojibwe Cree, Dakota, and Dene peoples, and on the homeland of the Métis Nation. We respect the treaties that were made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to the forward partnership with Indigenous communities in a spirit of reconciliation and collaboration. And good evening. So tonight, in our agenda, I'll just quickly go over that very quickly. So our beginner session will be Gail Wise, and she's going to be talking about bouquets of herdsmen. Then I will be doing announcements, and Brian Stack will do What's Up, and later on Dr. Michelle Boyce. We'll have a short break. And then afterwards, our main presentation will be Mark Irvine, and he's going to talk about a hike to the stars on Mount Lemmon, Arizona. So look forward to that. So without further ado, I would like you all please welcome Gail Wise. Gail Wise.
By his two hunting dogs, Asterion and Chera, which are the constellation Canis Venatici. We'll talk about them another time. The Romans saw 7 oxen in the stars of Ursa Major, pulling a plow behind them and tilling the heavenly fields, driven on by Boötes. And now Boötes is now known as the hunter on the tracks of the Great Bear. This constellation really is quite compact. It's squeezed in between Canis Venatici and Hercules. We have Virgo to the south, and Ursa Major and Draco the Dragon on the north. A lot of people see a kite shape in the stars of Boötes, and if you use your imagination, I guess you can kind of see it might be a kite. But most of us actually see it as a giant ice cream cone. Now, right beside it to the east is a small semicircle of stars, which is Corona Borealis, and that could be another scoop of ice cream that's fallen off of the cone. Boötes can be seen on just about any clear night since it's in the northern sky. In winter and early spring, it rises in the morning, and in late spring and summer, it's visible nearly all night. This constellation has been known for more than 3,000 years. Probably mostly to begin with for its brightest star, which is Arcturus. And you can easily find Arcturus by following the sweep of the Big Dipper's handle. Remember, arc to Arcturus. And beyond that, we can speed on to Spica, which is the brightest star in the constellation Virgo. We'll talk about her another time. Arcturus is the 4th brightest star in the whole sky, just in case you're keeping track. And it's the brightest star in the northern hemisphere. I always thought that Vega was brighter than Arcturus. But I was wrong. See, even I learned things doing these things. This is an orange-red giant. It's 25 times the size of the Sun, and it's 37 light years away from us. It's one of the closest of the bright stars. And that's one reason that it's so bright, is because it's so close to us. Arcturus was the very first star to be observed in daylight with a telescope. That was in the year 1635. And you can do this today if you use setting circles or your go-to. I don't like people to use a go-to. That's not hunting, but I will allow you to use your setting circles. The name Arcturus means the guardian of the bear. And it was on Arcturus that my pink telescope had its first light, so this star is a little bit special to me. To the Greeks, Bootes represented Arcus. He was the son of Callisto and Zeus. Callisto was a mortal woman, and Zeus was the king of the gods. One day, Zeus came to dinner at the palace of Lycaon, who was Callisto's father and Arcus's grandfather. Now, this was a very unusual thing for a god to do. Lycaon wanted to test whether his dinner guest really was the great Zeus. So he cut up Arcus and served him as part of a fancy buffet. What's with these ancients? But Zeus easily recognized the flesh of his son. In a burning rage, Zeus tipped over the table, scattering the feast, burned down the palace, and turned Lycaon into a wolf. Then Zeus collected up the parts of Arcus and made him whole again. Meanwhile, Zeus's jealous wife Hera realized that the birth of Arcus meant that her husband Zeus had been unfaithful again. And Hera decided to take revenge on her rival. Screaming insults, Hera grabbed Callisto by the hair and pulled her down to the ground. As Callisto lay there, dark hairs began to sprout on her arms and her legs. Her hands and her feet turned into claws, and her beautiful mouth, where Zeus had kissed her, turned into gaping jaws that could only growl. For 15 years, Callisto roamed the woods in the shape of a bear, but she could still think and reason like a normal woman. You could say she was smarter than the average bear. After Arcus had grown into a handsome teenager, he came upon the bear one day while he was hunting in the woods. Callisto recognized her son, and she tried to greet him lovingly. She stood up on her hind legs and tried to give him a big bear hug. She wanted to call out his name, but she could only growl. Not surprisingly, Arcus failed to interpret this as an expression of motherly love, and he thought the bear was going to kill him. So he got out. He's carrying a spear here. Most of the talks I do say he got out his bow and arrow, but in this case, he got out his spear. He turned around and was starting to chase Callisto. With Arcus in hot pursuit, the bear ran to the temple of Zeus for protection. But the temple was a forbidden place that was only allowed to gods and goddesses. Trespassers were punished by death. Just before Callisto and Arcus reached the temple, Zeus reached down and snatched them up and placed them in the sky. Arcus became the constellation Bootes, and Callisto became Ursa Major, the great bear. Another more popular myth has Arcus becoming Ursa Minor, the small bear, but that's a story for another constellation. Bootes is home to many bright stars, including 8 that are brighter than 4th magnitude, and 21 that are brighter than 5th magnitude. So there is a total of 29 stars here that are easily visible to the naked eye. And this constellation has a few interesting double stars. The best one is Izar. This is an orange giant, and its companion is greenish blue. Izar was discovered by Sir William Herschel in the year 1779. This is the second brightest star in Bootes, and the name comes from a short Arabic phrase meaning the girdle or the loincloth. I find that very surprising considering how high up it is. Most pictures I've seen of the ancient Greeks don't have them wearing clothes with such modesty. The primary star of Izar is magnitude 2.5, and the smaller one is 5. They have a combined magnitude of 2.4, so you can easily see it naked eye, but you'll need a telescope to split These two stars orbit each other every 6,000 years, and they're 203 light years away from us. Surprisingly, ISAR is not on the RASC's Explore the Universe list or on the double star list. I'm surprised because it really is such a nice one. Bootis is another double star. These two revolve around each other every 150 years. The main star is 5th magnitude, and it's yellow. The companion is reddish violet, and its magnitude is 7. The combined magnitude is 4.5, and they're separated by 6.3 arc seconds, so they are very close. This is only 22 light years away from us. It's very close to us. The RASC double star list has 4 that are in Boötes, so if you're looking for those, here they are. Iota Boötes, it's off my map. Imagine that this is all black here, and you'll see it way up there. This has the traditional name Asellus Secundus, which is Latin for the second donkey colt. Both of these stars appear blue, and their magnitudes are 4.8 and 7.4. Their combined magnitude is 4.7, and they're separated by 38.6 arc seconds. The star is naked eye, and you can easily split it with binoculars. Kappa Bootis is also off my map. Again, imagine it's all black here, and you can see it right up there. This has the traditional name Asellus Tertius, which is Latin for the third donkey colt. These two stars both appear white and blue, and their magnitudes are 6.6 and 4.6, and they have a combined magnitude of 4.4. They're separated by 13.5 arc seconds, so they're visible in a small telescope. And Kappa Bootis is approximately 155 light years from Earth, and it's in the same low-power field as Iota. Delta Bootis is approximately 121.8 light years away from us. It's also called Princess, meaning prime or prince in Latin. The magnitude of these is 3.6 and 7.9, and their combined magnitude is 3.5. They have a separation of 103 arc seconds, so it's visible naked eye, and it's easily split with binoculars. Mu is actually a triple star. 2 of these stars are widely separated by 108 arc seconds, but if you look closely, you'll see that the fainter one is a close double star. It's very much like Mizar in the handle of the Big Dipper. The system's traditional name is Alcalerops, from the Greek meaning a herdsman's crook or staff. This is kind of a messy slide, isn't it? I should have split them up some. On most sky charts that don't go to very faint magnitudes, Boötes appears to be quite sparse compared with its neighbors, but it does have its share of deep sky objects that are worth looking for. Virgo and Coma Berenices are so crowded with galaxies that very often we don't even know which one we're looking at. That is not the case with Boötes. The galaxies are spaced much farther apart, and they also tend to be a little bit more of a challenge to find than a lot of galaxies in the sky. The brightest galaxy in the constellation is NGC 5676. Its magnitude is 11.2. This is a spiral galaxy. It's not very big. It's 3 by 1.5 arc minutes, and we see it not quite edge on. It gets brighter towards the middle, and in high magnification on a good night, you'll see a stellar nucleus and some nice modeling in the arms. It's about 96 million light years away from us. NGC 5248 is a spiral galaxy. It's part of the Virgo cluster, but it's actually inside the boundaries of Boötes. This one is fairly large. It's 6.1 by 4.4 arc minutes. It has a bright nucleus and well-defined arms. Its magnitude is 11.3, and it's about 59 million light years away. You can see that it has a short bar, so it's classified as a barred spiral. NGC 5689 is another barred spiral. This is the largest in a group of 4 galaxies that are way up in a very empty spot. It has a bright stellar core, and we see it nearly edge on. It measures only 3.3 by 1 arc minute, so this one really is a bit of a triangle with two stars in the field, so that should help a bit. You can see one of the stars here, the other one's up there. So on a star chart, if you find those two stars and zero in imagining a triangle, you'll find it. There is one lone globular cluster in Boötes. It's NGC 5466. This was discovered by Sir William Herschel on May 17th, 1784. It measures about 6 arc minutes in diameter, so it's about the same size as M3, which is nearby. Its magnitude is 8.5, and that's really pretty bright for a globular. And with high magnification, you may be able to resolve some stars. NGC 5466 is also known as the snow globe cluster. This object is about 51,000 light years away from us, and it appears to be about 12.5 billion years old. It's visible in small telescopes and even in finders as a small, faint little fuzzy ball, and if you're in a fairly dark sky with an 8-inch telescope, you will resolve some stars. To the Shawnee people, there was a story about a great hunter called White Hawk. This story tells of a group of star maidens that would travel to Earth to perform a dance on the prairies. One day, White Hawk happened to see them. He marveled at them as he hid nearby, and he soon found himself falling in love. But he knew that if the maidens knew he was there, they would run away. So he used his magic to change himself into a mouse, and he crept close to them. He quickly changed himself back into a man and captured his love. All the others flew away back to the heavens, which was their home. His star maiden struggled at first, but soon she saw that he was kind and handsome, and she too fell in love. They were married and had a son, but she was not happy because she was homesick. One day she took their son and ran away back to the heavens. She lived there for a while, but soon she was unhappy again because she missed White Hawk so much. She presented her problem to the chiefs, who decided that they would allow White Hawk to join their tribe. White Hawk joined his family in the sky, and now they live there happily forever. Even tonight, when you look into the night sky, you can still see the dancers, but their dancing circle is incomplete because one of them is missing, as she lives with White Hawk. This constellation is known to them as the Celestial Sisters. To the ancient Greeks, Corona Borealis was the golden crown that was worn by Princess Ariadne of Crete. Ariadne is famous for her help in helping Theseus to slay the Minotaur. The Minotaur was a gruesome creature with the head of a bull on a human body. The Minotaur was imprisoned in a labyrinth that was so complex that neither he nor anyone who wandered in could ever find their way out. One day the hero Theseus came to Crete, and Ariadne saw him, and she fell in love at first sight. That's something that seems to happen a lot in these old Greek myths. When he offered to kill the Minotaur, Ariadne gave him a ball of golden thread, and she tied one end to the door of the maze. Theseus then went through, letting out the thread as he went. After he killed the Minotaur with his bare hands, he simply followed the ball of thread back to the door. The lovers then sailed away together to the island of Naxos. But no sooner did they get there that Theseus found another woman, and he abandoned Ariadne. As Ariadne sat there crying her eyes out, she was seen by the god Dionysus, who took pity on her. His heart melted, and he married her on the spot. That's something else that seemed to happen a lot. Aphrodite gave the bride a golden crown as a wedding present, and after their wedding, Ariadne joyfully tossed the crown into the sky, where its jewels changed into stars. So, if we are ever able to see any stars again, be sure and take a look in the direction of Boötes and Corona Borealis and my old friend Arcturus. The end.
So we've got a couple minutes before we start, before the 7:30, before we get started in a formal, to give people online so we don't start too early. So if you're good, I'm going to read you a story, Stories of the Aurora, by Joan Marie Galat, illustrated by Lorna Bennett. This one's called The Rainbow Belt, and it's a Wabanaki Algonquin legend. There we go. Okay, make sure they can. Sorry, I'm trying to make sure I'm in the camera for the one online. Chief Morningstar and his wife worried about their only son, for he did not like to spend time with children of his own age. In fact, he behaved very differently from the other boys in the tribe. Sometimes the boy took his bow and arrow and left the safety of the camp for days at a time. He never said where he was going or when he might return. He never talked about where he'd been, even when they asked him, "Where did you go? What did you see while you were away?" The chief did not like being ignored when he asked his son a question and decided to watch the boy more carefully. Like a warrior on the hunt, the chief blended into the landscape, his eyes following every movement and detail of his son's actions. He noticed the boy always carried his bow and arrows and walked north when he disappeared on one of his mysterious trips. One day when the boy took his bow and arrow up the trail northward, the chief told his wife, "I'm going to find out what our son is up to." She was afraid some harm would come to him, but knew he must go. "Return to me safely," she said softly, and watched as he followed the boy's path. The chief tracked the boy through the woods, then up and up the gentle sloping land. He stayed far enough back to avoid being seen, but close enough to never lose sight. They walked for such a long time that the land began to change. The trees became stunted and twisted. Soil gave way to rock, eventually changing from dark to lighter shades, until the trail they followed was completely white. The chief had never been this way before. He began to feel odd, almost lightheaded with each passing step. The feeling became stronger until he felt himself rising up into the air. At the same time, his memory slipped away. Helpless to what was happening, the chief's eyes closed, and he remembered no more. Morningstar did not know how much time had passed when the odd feeling began to finally disappear. He opened his eyes and saw that he stood in a strange land, bathed in a radiant glow. It was different from daylight, moonlight, starlight, firelight, or any light he'd ever seen. The chief looked up into the sky but saw no sun, no moon, no stars. He looked around for his son and was startled to see a group of people nearby. They looked somehow different from the people in his own tribe, but he could not say how. He searched their faces for his son, but could not find the boy. The chief saw the people looking at him with friendly faces and felt relieved that they did not want to harm him. He walked towards the group. "I am here to find my son," said the chief. "Have you seen a boy that does not belong to your tribe?" A man stepped forward and answered Morningstar, but he spoke using words the chief did not understand. Morningstar walked up to another group of people. "I am here to find my son," said the chief. "Have you seen a boy that does not belong to your tribe?" Again a man stepped forward, but this time he spoke in Morningstar's language. "Are you lost?" he asked. "Do you know where you are?" "I do not know where I am," said the chief. "But it is not a mistake that I am here. I was following my son, but now I cannot see him." "I know who your son must be," said the man. "Every now and then a visitor comes from the lower land to play ball with our people. You will see him soon." "But where am I?" asked Morningstar. "This is the land of the Wallaban, the Northern Lights." Now the chief knew what caused the strange light. He looked around and wondered. The man watched him curiously. "Did you have a strange feeling as you traveled here? Did you begin to forget what you were doing and why you had come?" asked the man. "That is how it was for me when I first came here from the lower country." "Yes," answered the chief. "That is how it was for me too. felt my spirit rising and my memory slipping away. Yet now I remember. You must have followed your son along the trail of the Milky Way. That is the only way here, said the man. It is called Ketaguswa, the spirit's palace. How do I get home? Asked Morningstar. I must take my son back with me. The chief of the Northern Lights can help you return to your homeland, said the man. I will talk to him after you see your son play ball. As he spoke, the players began to gather for the game. Morningstar stared in astonishment as the players placed shining bands around their heads and glowing belts around their waists. Those are called the Menkwa, said the man. They are rainbow belts. The players began to toss the ball back and forth. Every time someone touched the ball, tinted streams of light burst forth from the players' heads and waists in outpourings of color that danced and twirled and hung in shimmering sheets against the sky. As soon as the first streaks of light crossed overhead, more braves stepped out of the white wigwams to join the fun. The chief watched in wonder and noticed the rainbow lights that streamed from one young player were more brilliant than anyone else's. With a start, he realized he was admiring his own son. White, then green, yellow, purple, and red wisps of light flared from the boy. As Morningstar watched the game, the man who had spoken to him slipped away to talk to the leader of the people who lived in the land of the Northern Lights. He walked up to a brilliant white wigwam and called out, "A chief is here from the lower country. His name is Morningstar, and he seeks his son, the boy who comes every few days to play ball. The chief wishes to take the boy home with him." "We will honor Morningstar's wish," answered the chief of the Northern Lights. The chief stepped out of his wigwam and walked to the place where the ball players ran back and forth, shining with light. They stopped playing and looked at one another as they waited for the chief to speak. "Bid the boy farewell," said the great chief. "Our visitor must return with his father to the land below." The ball players embraced the boy whose colors shone the brightest. When they were done, the chief crooked one finger in the air, and two gigantic birds flew to the side. "Take the chief and his son to their home," he ordered. The enormous birds jumped in the air, wings flapping. One grasped the chief's shoulders, the other clutched the boy. The birds lifted their passengers into the sky and flew southward. Morningstar and his son knew they had reached the path of the Milky Way when their minds started to drift and their eyes began to droop. They remembered nothing else until they landed back on Earth next to the chief's wigwam. The chief's wife was very happy to see her son and husband again. She ran from the wigwam and embraced them both. From that time on, Morningstar's son stayed on Earth. He taught the men of the Wabanaki tribe to play ball, and his parents were pleased to have him here. The end. And before I get into announcements, what I do want to mention is, I'm not sure if everybody knows, but Wilford Buck, who is an indigenous person from the Paw, I think, I forget the name of this tribe, was honored this year with the Keelak Award from the RASC CASCA, which is the National Association of the Astronomers, Professional Astronomers, as well as the CAQ, which is the Quebec equivalent to the RASC. So it was quite a high honor for all the work. For those of you who may not know who Wilford Buck is, he's done many, many, many years of gathering stories of the night sky and from all the different indigenous nations, not just in Canada, but all over the world. So it's just to tie that together. We talk about it when we do our statement at the beginning of the land statement, but an acknowledgement that we'll work together. And it's just nice to see, because Wilford has spoken to some of our meetings, just to recognize and see that tie-in. Gail touched on it in her presentation with some other points of view rather than the Greek constellations and how people see it. And just another idea of how other peoples have seen aurora in this case. So with that, 7:30. See, now I did that time. As I mentioned earlier today, our beginner session is Gail Wise. Our meeting welcome is myself, Dennis Lyons. We'll also do the announcement. followed by that will be Brian Stack doing What's Up. What's new is Dr. Michelle Boyce. And our main presentation will be Mark Irvine, the stars on Mount Lemmon, Arizona. And then afterwards, everyone's welcome to come over to Boston Pizza. I have the wrong glasses here, so it's pretty hard for me tonight. So announcements, just to remember again that the Lockhart Planetarium at the U of M is open at different times. They announce it. The Observatory Committee, if you want to volunteer with it, but Dr. Michelle Boyce is in charge of the Observatory Committee. And probably next month we'll probably see more announcements on that. Spruce Woods, I gotta move my thing. So, and the Spruce Woods public event is the 25th of August. Celia Graga announced looking for volunteers on our Facebook page. She has enough, but if you're interested in going and you want to come and help, bring solar scopes and scopes for the evening viewing. So just if you're interested, and if you plan to go, please let her know that you're planning to go, and that's out at Spruce Woods. On the 26th, with a rain day of the 27th, is at St. Vital Park. We have an outreach event, and it'll run from 5:30 to 9:30. And if you're interested in volunteering with that one, please let Kamala know. And of course, Spruce Wood Star Party is the 14th to 17th of September. We put out a little announcement on a general announcement, and then in the general forum, there's a spot if you want to respond to or if you've got questions. That's where we would ask everybody to put their information and questions to. And if you're interested in volunteering, please let me know. For those that are aware of it, the Glen Lee, the floodplain has been split to the province. Ed Wright was coordinating that, and we finally completed and got all the documentation for it. So thank you to the people on the committee that were working to get all that, the Observatory Committee and others, to get all the documents in for us to submit, and we'll see if we actually get any money. We're going to have eventually establish a fundraising committee. We're looking for anybody who may be interested to chair that, or at the very least work with the council to put together all the policies and procedures around how the committee will work. So that needs to be developed. We're not recruiting for the committee, we're recruiting for somebody who would be willing to volunteer to spend some time putting all the details on how the committee will operate and work with council. Explore the Universe, Stan Runch. Stan's not here tonight.
Yes, he is.
Is he? Stan, there you are.
Boy,
Anything you want to talk about on Explore the Universe tonight?
I didn't prepare anything for tonight.
Didn't prepare anything for tonight. There you go. So that's fine. Telescope Lunar Program. I see Mike Krackus is sitting beside the Stan Runch that's not here. If you're interested in the lunar scope, please see Mike. Ty Spruce Woods, if you say, oh, I can't go to Spruce Woods because I don't have a telescope, the club has scopes. If you want to borrow a scope and come out for the weekend and maybe learn how to use that scope with a bunch of people and just have a really fun time, please see Mike. We have scopes that you can sign out and borrow for a month at a time. And highly recommend you do it. So don't let that be the thing to hold you back. Okay? And Members Night, we're also planning, it's going to happen tomorrow night, depending, Jay was telling me earlier, depending on which forecast. It's either clear skies or 30% cover. But it's a good night to come out, maybe look at the Perseids, if you've never done that, if you've got one of those reclining type lawn chairs, zero gravity, or whatever they call them. They're really good because you just lay back, chat with everybody, and go, did you see that one? Especially if there's a burner, and everybody goes, no, because they're too busy tapping to each other. So just please think about coming out to Glen Lee. It's just very simple. Of course, as it gets dark, and the darker it gets, and I'm sure Brian's going to talk a little bit about it, but out at Glen Lee tomorrow night. And just a reminder about the RASC board, it is still working and doing its thing, if you're interested. So just some information on the Spruce Wood Star Party, September 14th to 17th. It's open to RASC members in good standing, and so that just means, all that means is your membership is paid up. And it is open to any member of the RASC. Registration will open at 4 o'clock on the 14th. If you want to go out earlier to help set up, you're more than welcome. There will, as I mentioned on the Groups.io main page, there will be more information. Registration, Judy Anderson will be handling the registration. Volunteers or other information, contact myself. Cost is, $25. E-transfers are now accepted. Mark?
Yep.
Yep, so we now keep changing our banking and getting into the 21st century. So e-transfers can be sent to finance@winnipeg.rasc.ca. So it makes it simple that way. Ideally, we prefer if you do e-transfers because then nobody ever has to deal with cash when we're out at the event. And it's a very simple event. The agenda's been laid and sent out. It was part of the email that went out. There may be things added as we go, but it's a very laid-back, relaxed event. And if you haven't been to Spruce Woods, it's a wonderful place. We might have a talk on the next meeting about, for anybody who's new to that, what they might want to bring to the Spruce Woods Star Event Party. And if you're not sure, talk to some people, ask around here. We can give you some ideas about the basics of what you want to bring. Something to look up with and something to sleep under. Yes, Dan?
Is it $25 a person or?
Per person.
Per person.
Yeah. Just a reminder about Groups.io if you can't remember. So Groups.io, or you go to the, all you have to do to get to Groups.io is just Google Winnipeg RASC and it'll take you to the webpage. If you haven't got a membership yet, then you would just apply. You should already automatically get it from the RASC. If you don't, just submit. You'll be checked to confirm you remember the RASC Winnipeg, and then you'll be able to sign up, and that's our primary means of communication. And then there's several forums for different things, armchair astronomy, binocular groups, things like that, that you can pick and choose that you sign up to. As I mentioned, tomorrow is the members observing night, so hopefully we'll see a lot more people there. Maybe not as many scopes, but lots of lawn chairs. And again, it's still probably a really good night. If the sky is clear, it'll be a really nice night for observing as well, I would think. And with that, we'll introduce Brian Stack, who's going to do What's Up?
Hi, welcome back. It's been a while since our last time. So I'll talk about what's up for August 2023. Hopefully we got some good news for the weather, but like Jay said, the two models, my forecast looks like it's going to be pretty cloudy, but we'll talk about that later. Okay, so let's talk about a little bit about the planets and so basically, most of these planets, other than Jupiter and Saturn, are going to be visible in the evening. Saturn is going to be right after sunset, and whereas Jupiter is going to be after midnight. The other planets, Venus and Mars, is going to be kind of like early twilight, and Venus probably early morning, but most of the time it's going to be not very visible from our point of view. Southern hemisphere, yes, it'd be quite visible for them. But for the August events, of course, the big talk is the Perseus Meteor Shower that's happening tomorrow. It actually peaks Sunday morning, but Saturday night would be a good night. I'll talk more about that later. My neighbors were really big on the full moon, and I'm not big on the full moon myself. For this month, as you can see here, we have 2 full moons. They talk about being the blue moon, the super moon, or whatever, but for us, it's not very good because it brightens up the sky and we can't really see much about it. Okay, so as we have here, we have Mars and Mercury. Again, it's going to be kind of visible during just after sunset. That's happening today, but of course it's a little cloudy. But just kind of give you an idea where the planets are. This is kind of interesting here. Of course, this is happening tonight, but it's going to happen throughout the month where we're going to have Jupiter and the Pleiades system right next to it. And of course, in between, we do have Uranus. It might give you a better idea. I'm not big on Uranus and Neptune. They're very small planets to have a look at, unless you know what you're looking for. You got to tell the difference between planet and a star. But this is after midnight. It's not showing it, but actually on top of it, Starlink is going to be out. Okay, I thought this was really interesting here. So on August the 25th, this is very early, just before sunrise. Of course, you can see Venus there in the background. And then, of course, we have Orion. The winter constellation is going to appear quite early. So that's a hint that fall is appearing. But I came across the International Space Station. So I thought it'd be quite a sight if it's going to pass through Orion. Again, you don't really see it here, but here we're going to have a string of Starlink satellites coming through. So I thought it'd be quite a nice sight. As for the Milky Way, it is going to be directly overhead of us. But as you can see here, the core, we're going to lose the core throughout the night. So see, it's pretty early in the evening. This core is going to pretty much disappear. But it is going to be overhead. Now, I found this kind of interesting here. Saturn, they mentioned about the tilt earlier. Is it going to play automatically? Yes, it is. Okay, so I thought it was interesting. So just after sundown, we have Saturn here. Pay attention to the rings, because it's going to tilt. And this is going to happen throughout the whole night. So roughly around 3 a.m., we're going to look like it's going to level off. And it's going to tilt the opposite way. I kind of thought that was kind of interesting. And that's when the sun pops up. Okay, so we have this meteor shower, the South Delta Occurrent Meteor Shower. The reason why I mentioned this is because it is active technically. It peaked on July the 29th, but it's still active until August the 19th. So that means we have 2 meteor showers going. So what does that mean? We have a greater chance of seeing some meteors. So the Perseid meteor shower that's happening again, like I mentioned, tomorrow. I looked at every day for last week to see what's going to happen on average, what the weather's going to be like tomorrow. It looks pretty cloudy for me, but Jay said there's a chance that it could be 30% cloud coverage. Well, then you just don't know. The bottom line is head out there. I'm going to head out there with my equipment or a bottle of wine. And if it does work out, I'll be there. So what's good about this meteor shower is 150 per meteor. Shots every hour, but for last year, for the record, and realistically, we're looking at only about 40. This is my note from last year. Last year, we only had about 40 observed last year. Of course, it's the morning of August, so it's really Sunday morning that's going to really peak. The moon set at 1944. I did check the forecast for the smoke. I was going to show it, but then the forecast for tomorrow and for the next couple of days is going to be clear. So we don't have to worry about the smoke, and it looks like it is clearing up for the most part. Of course, it is around the new moon, so we've got a lot of things going for us. One, it's a weekend. 2, Saturday. And then, of course, it's around the new moon, which is kind of rare for us. And just pray to God that we have some clear skies tomorrow. I'm praying to God right now that it's going to happen. Okay, now for the forecast here. Again, looks like the relative humidity is going to be quite high for the next 3 days, as you can see here. So if it's not going to be cloudy, it's going to be quite dewy. But then again, we do have a little bit of wind, which I don't have here. As for the temperature, it's still going to be above 10. Now for the forecasts here, for the cloud coverage here, of course, no big surprise. We're going to have lots of rain, as you can see here. This kept on changing every day. But it's still right here. This is Saturday's right here. So 12 a.m. We do have a little bit about 30% cloud coverage here, like Jake said. Every day before that, it was pretty cloudy. Next week looks really clear, as you can see here. Sunday, 1 one time there was forecast being clear, but yeah, so we do have some bit of clear skies tomorrow, but we'll have to wait and see. All right, so I think that's it. That's all I have for What's Up for August 2023. Thank you.
And just while we get set up, I'm just going to be a proud uncle moment here for a second. Brian mentioned the ISS. I have a nephew, and he flies aerobatics, and he does a night show. And in Oshkosh here a few weeks ago, while he was doing his air show, the ISS went over, and they got a cool stop motion video. It's just really cool. So they captured the ISS flying over while he was doing his night show. So, yeah, Jane.
Brought a bunch of books to give out again there on the front desk there. People can help themselves, and somebody else brought some of those magazines.
Okay, so if you didn't hear that, Jane's brought it. There's a bunch more books for free up front. Just help yourselves at the break. And please welcome Dr. Michelle Boyce while we get everything all set up for her.
Okay, so we'll do what's new. So this is just some stuff I pulled off the internet, actually, and some research I'm working on. Oh, there we go. So James Webb Telescope is busy doing lots of things, and I thought this was interesting. This is the first direct detection of a planet by James Webb Telescope. So here, this is HIP 65426b, whatever. So this is I believe it's a gas giant. It's 1,000 times fainter than its star. But James Webb has basically a sort of a coronagraph mask that dims the light so it can take a photo. It's likened to trying to take a photograph of a moth next to a floodlight several miles away. So it's actually performing much better than they had estimated. And this system is about 100 AU away, and 1 astronomical unit is basic distance from the Earth to the Sun. So it's, yeah, actually that does not sound right. Okay. Yeah, I don't think that's the correct distance because Pluto is about 40 AU, so I suspect there's an error there. So I'm just going to quickly mention the image methods. I've probably mentioned this before, but direct imaging is when you try to look at a planetary system with a telescope. And we can only see things that are relatively close, mainly because it requires a lot of resolution, and also the system has to be, we have to be looking at the top or the bottom of the system in general to see this. So that's the direct one will probably detect a lot more. And through the direct method, well, actually many methods, you can use the Astrometric Method, which is basically, if you're looking at a star and you see the star shifting around over a period of time, then you can actually figure out from the mechanics what planets are orbiting around it. So this is an example of the motion of our sun seen over 65 years, seeing 30 light years away. That's how long it would take to get a sense of the planets and their orbits. And this is the path of the sun that's moving, and you can see it's a very, very small distance. An arc second is 1/3600th of a degree, so you can see it's a very small change in motion that you'd have to observe. And as such, you're limited by the distance, again, because of the instrumentation. Then there's the Doppler method, which is more common. So if you have a star and there's a planet moving around the star, as it comes close to you, becomes blue shifted. As it goes away from you, it becomes more red shifted. And then the other popular method is the transit method. Looking at a star, planet goes by it, you can notice the drop in intensity, and from that you can determine the orbital properties of the star. And these days, of course, if you look at the star, and you look at a light coming from the star, and the planet crosses in front of the star, it will change the spectrum because of the atmosphere of that planet, and then you can actually analyze the atmosphere. So I showed that once for James Webb, one of the first atmospheric analyses. And so this is just a quick table. It's direct, astrometric, Doppler method, and transit method. And you can see for the direct method, this is from 2015, but there's very few detections, and even for the astrometric method, and that's for the reasons I mentioned. Doppler method, there's about 600. For the Doppler method, the system has to be somewhat edge on, because if it's like this, you don't see any Doppler effect. And same for the transit. If you're looking from the top, you'll never see a planet transit the star. So these are edge-on detection. But you can see this is the most popular method, the transit method. I forget when I mentioned this. This is several years old. The Evolutionary Map of the Universe, it's a radio survey that was done probably about 3 or 4 years ago. And this was published and put up. Jan English is, you've probably heard her talk before. She does a lot of composite imaging and has received awards for it. So here, this is a composite radio image and optical image. So here you see these 2 galaxies and these jets coming out. So you can imagine that you have a galaxy. At the core of the galaxy, you have a black hole. Black holes tend to have high magnetic fields, so you have an accretion disk, and some of that material gets spit off in jets from either side. And they're not necessarily visible near the star. You might see something in the ultraviolet, which is high energy, but you'll also see radio emission because charged particles are in the magnetic fields. When charged particles move through a magnetic field, they emit light. And in this case, it's synchrotron radiation, which is picked up by radio telescopes. And you won't see that in the optical range. So this is, what you're seeing here then are these disks. And the reason there's an arc is because it's probably moving through some intergalactic medium that has gas and dust. So as that moves, it gets bent. And then here you can see this puffiness here. These are probably due to shocks where there's a dense amount of gravity. So the jets are slowing down and then they end up ramming into dense pockets of gas. That's the thing, our galaxy has a lot of gas, there's a lot of gas in the universe, and that really affects things, okay? So here we can see these 2. So the question is now, are these orbiting around each other, or are they just separate entities maybe? And there was a paper put out, well, it came out this year, and it's by Belmore et al. And they did, so this is a Meerkat image, which is another telescope. So this one is from ASCAP, Australian Square Kilometre Array. And the survey is called the Evolutionary Map of the Universe. So they did the survey with this radio telescope. Now, this is actually part of what is becoming the Square Kilometre Array, which consists of a series of telescopes in Australia and South Africa that, when put together in interferometer, they're equivalent of a 1 square kilometre radio telescope. And that's being developed. So Meerkat is in South Africa, and it has a different frequency range. And what you're seeing here is a look at the dancing ghosts with various frequencies. So just like if you're looking at a star, you can use different filters and then superimpose those images. It's the same in radio. And what happens is when you get a radio image, they call it a data cube, where you have radio frequency this way and then your XY intensity. So that's what you're looking at here, sort of cut away. And then you can see these hot spots here, and not, so there's a hot spot along there, so that means there's something happening with the jet. And then it's part of Able 375 galaxy cluster. So here's the dancing ghost, and these are other radio images that were detected in this cluster using through the EMU survey. And so it could be that maybe there's a dynamics going on between in the whole system. Their paper sort of surmises that there may not be anything going on. So what I've been doing is I'm looking at modeling it more carefully. So here's a model of a system of 2 galaxies orbiting about each other. And so you have to get all this information from optical and radio and stuff like that. And then you do a model. And in this case here, they model this by assuming these jets are spitting out particles. And then they compare this to what they see in the image. I should have put an image here, but they compare that to what they see. And that gives them a sense of the dynamics of whether they're rotating around each other. You can also just do it for a single galaxy that's rotating about some center within a large body. So you can also do this. And so maybe they're separate entities in Able, and they're not moving around each other. So I'd have to model these and find out. And I may end up just coming to the conclusion that it could be either or, because it may not be enough information. This is where I am right now. This is a spectral index mapping for age determination. What that means is that when a jet of particles leaves the black hole from the center of the galaxy, the synchrotron radiation spectrum changes over time. And from that, you can actually, from the physics, you can figure out what the age is as you leave that, as you head down that particular jet. So this here is a spectral index map, which is basically how the frequency changes as you move away. And from that, from some modeling, then you can actually figure out the spectral age. But you would need several different frequencies to do these maps. So this is something I'm working on in R Studio at the moment. Then I just thought this was interesting. Web captures a stunning image of the Ring Nebula, one of my favorite objects. It's easy for me to just hop to it. I'm slowly working on hopping to different objects, but it is rather challenging. But once you find the object, it's easy to get there. I finally found last star party, I found the Dumbbell Nebula. But every time I tried to, with binoculars, every time I tried to wing my telescope over it, clouds just came over. So one day I will get you. But and remember the DART mission where they impacted into an object? Here we have the Didymos and Dimorphos, so it's a binary system. And then they took this probe and just smacked it to see if it would disturb it. And the idea is, can we divert any impactors to Earth? So the interesting thing about this is like a mini solar system. You have a body here, something orbited, can you change to orbit? Okay. It never mentions that anywhere, and you just get confused as heck trying to figure out how does it move the whole system. You think it's diverting the whole system, but it's a miniature lab. And so this image is from Hubble, and this is, how many months later? This is several months, taken several months later. And you can see all this dust and little particles from that impact streaming out from that system. Anyway, that's what's new. So, yeah. Any questions? Questions? Yes.
I was interested, it looks like you were sort of showing some of your actual research that you're doing on the galaxy.
Yeah, I call myself a freelance researcher because I don't get paid. Anyway, yes, sorry.
So you said the synchrotron radiation, you could use that for trying to calculate the age. So it's the age of what? Of the jets or the galaxy?
Imagine a water hose. It sort of does this, and then as you get out further, it just trickles down and dies and falls, right? So you could imagine that synchrotron radiation, and its intensity is dropping. And imagine that takes so many seconds to get over here, right? And so if you know how that behavior of that is, you can actually calculate the age. And it's the same thing with synchrotron radiation. Does that answer your question?
So it's kind of the age of the jet.
Yeah, because you're modeling it, but the jet doesn't appear like that, right? That's a galaxy, right? And like our galaxy is 100,000 light years across. So it will take time for that jet. And so you could get the age, you work out the dynamics, the jets get spit out, and you can figure out how fast the jet is and how fast it's slowing down and all the gas. So you get that information from it. Yeah. Yes?
So what's the magnitude, like really roughly, because you haven't done it yet, but what's the magnitude of the age of the jet? What do you?
I don't know. I haven't gotten there yet, as you said. I haven't done the calculation yet because I have to take several radio images and figure it out. I've just finished mapping. This is a spectral index map that I finished doing, which is basically related to how fast, like your water falls or whatever. So it's related to that, but now you have to figure out the physics to get the age as you go along, and that requires several different frequencies of radio images. So I don't know right now, and I haven't looked at the intensity. I mean, the intensity is right there on the picture. There's a black and white image of the dancing ghosts here. That's a black and white. Sorry, it's a radio image, so yeah, whatever color you like, right? So that gives you a sense of the intensities that you're dealing with. Okay, and that's averaged over a range of frequencies, that particular image. Any other questions? Okay, all right.
Thank you very much.
Yeah.
Michelle Boyce. So we're going to take about a 15-minute break, so by my watch that'll be about 20 after. And just before you go, what kind of dish is out of this world? A flying saucer. See you in 15.
Wow.
Got that one from your kid, not coming back.
Pretty good though. We welcome Mark Irvine, who is going to speak to us tonight about his hike to the stars on Mount Lemmon. Please welcome Mark Irvine.
The title's wrong. It's actually the financial statements of the Royal Astrometric Method, Winnipeg Center. I'm just kidding. Nobody can't hear anything. He says, they say they can't hear anything yet. Is this mic on mute? Oh, there we are. Is that better? Everybody, you can see me, and everybody can hear me. Okay, well, first of all, that background image is from the top of Mount Lemmon looking down on Tucson, which is 15.5 miles away. And now he's got to change the page. There we go. Okay, where's Tucson? Most folks, a lot of folks have driven there, I think, from this club. It's about 30 hours by car. I didn't do that. We flew down to Phoenix, and from Phoenix, it's about an hour and a half. No, it's about, how far is it from Phoenix? 129 miles, a little over an hour and 15, 20 minutes from Phoenix. I skipped ahead too far. Let's go up. There we are.
Get rid of that.
Can I move that down? Okay. All right. Tucson is a city about the size of Winnipeg, located down Highway 10 from Phoenix. Mount Lemmon is about 15.5 miles from Tucson on the Catalina Highway. And the excursion up to Mount Lemmon is a 1.5 to 2 hour trip, depending on the number of stops you make. I showed this one other time, but it's about a 30-hour drive or 2.5 hour flight. Well, when I get down into Tucson, one of the obligatory stops was, it's pretty hard to see, but it's Starzona. Some of you out there will recognize Starzona and Dean Koenig, who's the owner of Starzona. I stopped there on my way by, regardless, and it was daytime, so we popped into the store and had a look at some of his equipment. Of course, the Hyperstar is built by Starzona, as well as Hyperion telescopes. And coincidentally, my wife is not an astronomy fan, found a thrift store next door. Salvation Army family thrift store. So while I was in Starzona, Caroline was over at the thrift store. I think I've said this to a few folks as well, that Starzona actually hosts weekly a little mini star party on their parking lot. So if you buy equipment from them or you have issues with equipment, you attend on their parking lot. They have some experts and staff from the store that pop out with electrical cords, and we actually start to work with different telescopes and equipment on their parking lot, which was quite interesting. And I talked to a lot of folks there, probably for an hour and a half. We just moved around the parking lot, looked at different objects in the sky. In Tucson, there are a lot of light restrictions, so the lights that are coming off of things in the background are actually, quite well controlled. They're pointing down and they're quite bright, but not a lot is going up. So our skies are actually pretty good, just from the parking lot of Starzona. And those are held weekly, and it's a big promotional thing for the store, but we found it quite interesting to talk to different people from all over the state, primarily that, and some of course new folks who bought new equipment who didn't know how to use their things, but a lot of folks were here just to get things troubleshot. Well, starting on the trip to Mount Lemmon, we started as a couple. We wanted to visit Mount Lemmon regardless of the observatory because of some of the other aspects of it. There's a series of ecological zones up the mountain as you go. It starts out, of course, as desert at the base level, grassland, woodland, and forest as you go up, as the temperature drops and the moisture level increases. And another look at the objects that we see as we go up the mountain. Soharo cacti, Babag Doag Trail, which is one of the native or aboriginal tribes in the area. And as we go up, we see the various different objects and highlights of the canyon trail, or the Mount Lemmon highway. Here's a scene of kind of the desert flora and fauna. And we get up into the hoodoos as we go up the mountain. Lakes, which kind of more reminiscent of Canada. This is all still on the same Mount Lemmon. And of course, near the top, but lower than the observatory site, is a ski hill. Of course, we get to the top and we have the Stewart Observatory, which is managing the Mount Lemmon Sky Center. And you'll see in the background a remnant of the military radar establishment that was on the site. This is a copy of the footprint. Just going to move this a bit. Get it over That's a footprint of the Astronomical Observatory site. We come in on the parking lot on the right-hand side to the visitor center, and then we are moved by a van, because no one's allowed to basically walk on the site unless you're staff. You're moved and controlled by van from the parking area here over to the student classrooms and dorms, and then into the public telescope area at the top and on the left there. You can see at the top here is the Catalina Sky Survey, and Biosphere 2. The Catalina Sky Survey is actually responsible for half of all the near-Earth object discoveries since 2012. So anyway, our tour up the mountain, we found an app that's produced by the University of Arizona, and it's called the Science Tour. And the application basically runs like a podcast. You start it in your vehicle, or whatever your vehicle has, with CarPlay, or you use an iPod or an iPad or whatever it might be. You set it up in your car, and basically it'll take you up the mountain at the posted speed limits, and it'll take an hour and a half to 2 hours, depending on the stops you make along the way. And they divide the highway up into sky islands, rocks, life zones, water, forest, and fire. To get to the mountain, you're coming from Tucson down the east Tangue Verde Road, and then hit the Catalina Highway. The Catalina Highway takes you up to Mount Lemmon. This is just a picture of how we started the tour on the Catalina Highway. We start the tour at a particular intersection. They mentioned the intersection in the application, so you get to the intersection with the sign up that has the two street signs, showing the intersection, and you start the application, and then you proceed along the way. And basically there's a narrative that takes you up the mountain. Well, a little bit of history behind Mount Lemmon, and Ed sort of alluded to a bit of it in the introduction he did to the presentation. Mount Lemmon was named after botanist Sarah Plummer Webb, who trekked up to the top of the mountain back in 1881, and she was accompanied by her husband, E.O. Stratton, a local rancher. And basically at the time, the land was owned by the Aboriginal tribe of Badad-Walag, or Frog Mountain. The Tohono is the actually name of the band, sorry. Tohono O'odham, O'odham, which were actually bitter enemies of the Apache, which also occupied the same area. Mount Lemmon Observatory site was first developed in 1954 as an Air Force station and radar installation of the Air Defense Command. Upon transfer to the Stewart Observatory in 1970, the site was converted to an infrared observatory until 2003, and then a radar tower operated from Fort Huachuca, and was used to track missile tests and launches from the White Sands Missile Range and Vandenberg Air Force Base in California. And although the United States military had a presence on the mountain for several decades, their facility has been abandoned, and were given over to the United States Forest Service by the University of Arizona, and then from the Forest Service to the University of Arizona. And the telescopes on the mountain are still used for astronomical research today by organizations such as the Catalina Sky Survey, Mount Lemmon Sky Center, the University of Arizona, their astronomy camp program, University of Minnesota, and as well the Korean Astronomical Association. There are 8 telescopes located on the Mount Lemmon site. There's the Stewart Observatory Telescope, which is a Cassegrain reflector used for the it's part of the Catalina Sky Survey. And again, the Catalina Sky Survey has been responsible for half of the near-Earth objects identified since 2012. Second telescope is a 60-inch, 1.52 meter University of Minnesota telescope, which started operation in 1970, a Dahl-Kirkham optical near-infrared, and is of the same general design as the Stewart telescope. Third telescope is a 40-inch, 1.02 meter reflecting telescope, and is an unusual Pressman mechanical design. Not the greatest of mounts, and is used to provide automated follow-up observations for newly discovered near-Earth objects. The 1 meter or 39-inch CASI robotic telescope was installed in 2003 and is the only instrument in Mount Lemmon operated by the Korean Astronomical Space Society. And given this time zone difference, the people at Mount Lemmon were a little jealous of the Koreans because they could do their astronomy during the day. The Schulman telescope, which is the one that was designed specifically for outreach, was installed back in 2010 and is currently Arizona's largest dedicated public observatory for outreach purposes. Sixth is a telescope installed in 1963, 28-inch reflecting telescope, and is used on the site and has been there since 1972. A 24-inch Richard Kretchen reflector built by RC Optical Systems, again operated by the Sky Center. And lastly, the John Jameson telescope, which was donated in 1999, dedicated in 2005, and is optimized for near-infrared observing and is at the Mount Lemmon Sky Center. Now, University of Arizona Department of Astronomy is very involved in outreach, and as you can see from the website here, a good chunk of their program is addressed to the public. And so one of the things that's key to the donor, which was Joe Schulman and his wife Dixie, they wanted to inspire the public. So they actually met Adam Block, who, quite a famous astrophotographer, and Adam inspired Joel Schulman into making a donation. So the Schulman Trust actually donated the funds for this Schulman telescope, and it was over $1 million. And that was the start of it. It happened back in 2006, and the telescope was installed in 2007 and has been operated by the University of Arizona Sky Center since. Now, if you are interested, when you get down to Tucson, you look into the University of Arizona's website, and you're able to purchase tickets to visit the site and attend on their astronomical excursion. And it lasts about 5 hours. You're going from 3:30 in the afternoon when you come in, and then it lasts till 11 at night. 9:30, well, actually 10:30, 11 at night, and they don't really close the gates until the last person's gone, and there's people up there, doing some of their own astrophotography and expressing interest in using the Schulman telescope themselves. The attendees actually, or the teachers who were up there helping us with the telescopes, were allowing us to use our own cameras on the telescope, and which was, basically, they have some latitude when they're teaching various classes, and if you express interest and have some knowledge, if you ask them, they will allow you to mount your own camera into the telescope and take some pictures if you desire. This is the gate to the top of the park. Basically, the access is restricted, so when you get up past the ski zone, there isn't a road that's fairly rough. It takes you up to another parking lot, and then at the head of the parking lot are these gates. And depending on the time of year, of course, this would be more in the summertime, and the left would be more in the winter. When we were up there was snow. That was November. The base of the hill would be in the 20s. The top of the hill near zero, or a little bit below zero, so Fahrenheit 32 at the top, between 28 and 32, and down below you'd be in the 70s, high 60s, low 70s. Now the outreach program is basically what they do with you when you're out there. So after entering the Mount Lemmon Sky Center, you begin looking at the refurbished site. So you get driven around the site in their van, because they don't want you walking anywhere. They want to control you. Plus, I think it was, it was COVID time, so they just really wanted to make sure that they controlled everything well for us. Once in the Learning Center, the presenter introduces us to the facilities, the mountain elements of the program that we soon undertake. The guests will then eat a lunch. We go to the student center in the classrooms, and they provide a lunch to us. which is around supper time, usually around 5 or so. And it's a light lunch, sandwiches, cookies, that kind of thing. And then basically they give us the lay of the process that we're going to follow as we go along in the program after the lights go down. We still have some time here, it's only 5, but shortly before sunset, okay, after we eat our lunch, then we go outside, and shortly before sunset, 60 to 90 minutes, we get escorted around the site, and like we get taken in the vans, and then you're actually walked around the site. And then we head up to the observatory areas, because they want us to orient to the equipment while it's daylight, and we can see. So we actually get to the Schulman telescope and the observatory dome at daylight, and we can see where the footing is, where the different objects are around the dome, so we aren't tripping and falling as bad or too badly. Then we head up to the observatory and wait for the sky to become dark enough for stargazing. Once deep twilight has fallen, we step outside briefly for an orientation using binoculars, and then we look at some of the brightest stars and constellations, as well as a number of deep sky objects visible through binoculars. And often, they mention there's surprises out there with satellites and meteors and so on. The sky orientation begins 25 to 30 minutes after sunset and lasts 30 to 45 minutes. And then finally, after the orientation, we get to use the 32-inch Schulman and 24-inch Phillips telescopes. And we see everything from planets, galaxies, deep sky objects include, star clusters, nebulae, galaxies, stellar spectra. Every season offers different astronomical vistas. And then from night to night, depending on the presenter or the leaders, they may have different things for us to have a chance to look at. Part of the orientation, again, during the daylight is to look at all the different equipment on the site. They have some equipment that they pull out from the domes and allow us to use. This is some solar observing we were doing on the site just after the initial orientation. And then, of course, the Schulman telescope is a 32-inch on the right there. And this is the classroom setting along with the warm room and washroom facilities and behind. This whole thing was donated and built from the funds from the Schulman family, Joe and Dixie Schulman. The van there is how they took us around the site. This is the Phillips telescope behind us there. And that was kind of right before sunset. They actually take us out to the edge of the facility grounds and were photographed at sunset. The classroom basically is set up like any other university classroom. This is where we had our meal, and then we had some instruction around the equipment, as well as some current events in astronomy and things that the Sky Center is up to, and work that's being done by the Arizona, or the University of Arizona at the Stewart Observatory. And this is just some, like all ages are attending on these sessions. So we have a young boy there looking through the telescope. And I believe this is probably, it's darker than it appears, but we wouldn't normally be looking with the telescope in the, out past the, into the daylight, but some of that may be staged. Anyway, the telescope, these are the specifics of the telescope. The Schulman telescope is operated by the Mountain Island Sky Center. It's dedicated, or Arizona's largest dedicated public observatory. The Schulman telescope was designed from inception for remote control of the internet by amateur and professional astrophotographers worldwide, and is currently the world's largest telescope dedicated for this purpose. And these are just some of the specifications around the telescope. Focal length, 5.6 meters, and f7 equatorial fork. And just some other perspectives of the telescope and the dome. The site was, of course, being where it was, quite an excellent site, which was one of the stipulations made by the donor when he spoke with Adam Block, that whatever donation he made, it had to be an excellent site. And of course, Mount Lemmon was selected as the lucky location. Operating the telescope, we had some instruction from the technicians around the telescope. The camera is a CCD camera built by SB. It's the CAF 16803 chip, and it's a full frame camera. The resolution and 9 micron pixel size, if you're familiar with the camera. Astrodon Generation 2 broadband filters, as well as H-alpha narrowband filters. The acquisition was completed with the Sky software BISC. They were still using Maxim DL and Cyanogen. The technicians weren't all that impressed when I spoke to them about it, but because they felt that this was a bit dated, but they still get what they need to get out of the telescope and the imaging. And what really is phenomenal is the fact that you can get 300-second unguided images out of the telescope. So that means, they do have a guide scope on it. The guide scope is better than anything I have. It was 150, I think it was a 10, 140 apochromatic, and that's a guide scope for this one. The observatory control is a ASCOM compliant ACP astronomer control panel, is the title of it. I probably asked more questions because I enjoy astrophotography and I have my own equipment. So a lot of this stuff was of interest to me. We actually let to drive the telescope as well. You could sit down and direct it to where you want it to go. If you had a particular object in mind, something obscure. I mean, one of the things was there was 20 other people. So whatever you decided to go to had to be of interest to somebody else. So obscure objects weren't going to be something that they really wanted us to pick. But you could select and drive the telescope to where you wanted it to point and the object you're interested in seeing. Some of the images, of course, coming from the telescope include planetary items and deep sky images, of course. And these are some award-winning APOD images that came from Mount Lemmon by Adam Block. And again, using the equipment that we see, excuse me, in the pages past. Looking on, Arizona is a big state, and there are a lot of telescopes in that location. Kitt Peak is another location. It's not far away. It's about 2 hours southwest of Mount Lemmon. And it's on the Tohono O'odham Reservation. And of course, they also have outreach programs. The Fred Lawrence Whipple Observatory is another location that has telescopes in the general area. Again, 2 hours away from Mount Lemmon. And of course, there's Lowell, which is 5 hours north into Flagstaff. But again, if you're interested in doing an astronomy tour, these locations when they're open, some of them are not open, but the locations when they are open have basically you're ready to buy tickets and attend on one of their programs. These are the useful links if anybody's interested. I think that was about all I had for you guys. Yes. Back my notes here. If you need tickets are $85 a piece to attend through the website. The idea is that they want folks from the public and novices to be able to attend on, and use the equipment, become inspired, and become advocates for astronomy in the state, in the university, and wherever they come from. So part of the issue is, or part of the promotion of the item is for the public to actually get involved. And I think that's about all I've got on this thing. It was quite by accident that I was able to actually attend this, because I had planned to only take star trails when I went up to the top of Mount Lemmon. We had taken that science tour, which was about 2 hours, so we went up the mountain on the tour, got to the parking lot outside the gate, excuse me, and parked the car, and there were other people parked there, and I started a conversation with my neighbor and asked why there's so many people parked here. I was planning to stay there to do star trails in the parking lot, because no, there's a course starting here in 10 minutes. And I went, oh, really? And yeah, go to the guy at the gate and see if there's an opening. And so I did. Walked up to the fellow at the gate and said, okay, is there any openings for your course? He says, as a matter of fact, there was a family stuck coming south from Flagstaff and couldn't make it. I have an opening. So are you guys, if you're interested, we'll get you in. So sure enough, I guess we really had no other plans. We're supposed to be, we were supposed to, I guess, just go back and have supper, but went back and checked with Virgo and said, are you game for it? She goes, sure, this is your thing, right? We're going to enjoy this. I go, well, no guarantee, but I think it'll be fun. And so yeah, we registered, got up to the site, and started to travel around. And, the 5 hours went fast. It was, I mean, seeing all the equipment, the domes, and then being able to talk intelligently with the technicians about the nature of the telescopes, how they function, what work they do. In particular, the Catalina Sky Survey. And they also did, I guess I'm trying to remember the word, photometry. They were doing work, but they work in sync with all the other observatories in the state. So they all are coordinated and do work together. But the key thing, I guess, that this particular location was for, is the sky survey and the near-Earth objects. So they're quite proud of their work there, and the fact that their particular location, and managed by the University of Arizona, was responsible for identifying and cataloging all the half the near-Earth objects since 2012. So anyway, I think that's all I've got. Any other questions, or any questions for you guys?
Any astro pictures from him?
Pardon me?
Did you do any astro pictures?
Did I do any astro pictures? In the end, some, but not worth showing. Yes.
Still get to do your star trails out?
No, I mean, by the time I finished up on the site, it was actually, I was a little bit nervous driving down because it's black. And we're driving down a 2-hour trip down the mountain in the dark. And really they don't, we do have lights on, but they don't want you using your lights. And so we have to actually kind of drive with parking lights and limit it. Then you basically follow the tail lights of the guy in front of you and hope the guy, once you got down to a certain level, like below one of those eco zones, then you could turn the lights on, and then you were able to, or actually use your full, your high beams, because it's a winding road up and down that mountain, and especially coming down at night, it was tricky. So I didn't get a chance to do any astrophotography, but you know what, I didn't care, because to be on that site and to be exposed to those telescopes was something I wouldn't have otherwise had a chance to do. And it was just by accident that it happened. So it's a fortunate accident, but one of the benefits of that is I can bring it back to us here in Manitoba. And if you decide to take a trip to Arizona and down into Tucson, I mean, there are innumerable locations that are very similar to this, but I have to talk about, well, Mount Lemmon was terrific, and a terrific experience. They design it for outreach and for the public, and if you're interested and you're in the area, and a lot of us winter down there or choose to winter down that area, that's something that you should really look into. It's a reasonable price for a 5-hour adventure in astronomy. Thanks. Any other questions?
Have you tried?
Yes, Judy.
Have you tried the remote access?
Well, we actually, when we went back to the classrooms, we were working with the technician. I was, myself and one other guy from Wisconsin, were sitting beside the technician as the remote people started working. Because as soon as we were off the telescope, he has to signal that it can be released. And he did that, and all of a sudden, boom, everybody starts piling in, lining up to use the remote capability of the telescope. So he says, watch this guy. And he's been on here a few times, and he basically, he knew exactly what he wanted. He had a limited amount of time. He had the telescope focused on what he was doing, and he said, watch what he does. And we did. We were able to monitor what the fellow did from, I can't remember, it was Singapore, or it was, anyway, it was way, way across the world. And he had a specific object he was after, and we were basically able to sit back with the technician and watch him steer the telescope. And then you see the dome, you can hear it from the classrooms, and see the slit move, but it's dark. And basically you're dealing with a very, very dark site compared to maybe what I've experienced around Manitoba. I mean, the only place you might compare it is out in the middle of Lake Winnipeg. If you're in a boat, it would be very dark. And there it's very dark, very dry, no dew. Basically, trying to just see your feet when you're out past the telescope dome, just to see your feet was a trick. So they actually made sure we all had these little red flashlights. They were a little mini flashlight that had a button on it, so you could actually point it down at your feet so you knew where you were walking. But yeah, we had a tremendous time. Yeah, Mike?
Was there a certain highlight mark, or one experience that you had that just really, what was your takeaway?
I'm going to say looking at Saturn from the 32 inches.
I'll be there, buddy.
Oh, it's crazy. If you see, and some of the reactions of the other public, that's amazing. You see it when you use your own equipment. Like, we all stand back and we get amazed when we use our own equipment in public outreach with the reactions. And to see and experience the reactions of those people, and it's like, because a lot of people sign up for this thing on a lark. They just, okay, well, it's something to do. I'm going to go up here and I'm going to look at this thing, and then all of a sudden, something like seeing a planet, Jupiter. Well, Jupiter was at the end, because it really, once we looked at Jupiter, you were ruined for the night. It was so bright. You had no night vision left after you looked at Jupiter. And they set it up that way. So you looked at dimmer objects first, and then they drew you over to the planets at the end, because really you just started seeing spots after you looked at the planets. And then we started plugging our cameras in and taking pictures. And it was mostly cell phone photography that people were doing. But if you had a 2-inch, fixture for your if your regular camera, that would have slipped right in there, because when we left the telescope, it was a very simple thing for them to open a drawer, pull out the camera, plug it in. Everything was, they had like measurements on the side of the telescope where the camera actually, so they don't have to redo their flats and other things. They have it precisely calibrated so that the camera goes in a certain way in a bracket, so that basically when we leave, everything is set to go for the people that leave space and time on it. Now that's kind of critical, I guess, so you don't have to redo flats on the telescope. You have to have a bracket that the camera fits into, so it puts it in exactly the right spot. But of course, you're jealous. There's no way I could afford anything like they have. But and the fact that you could do unguided imaging for 300 seconds, with this giant mount was phenomenal. And then when they threw a guide scope on it, and the guide scope was a Tech 140, with these amazing eyepieces on it. And then people would line up to look through the telescope, but also the guide scope. Because you could see almost as good through the guide scope as you could through the Schumann. You got a little more light through the Schumann, but both telescopes were phenomenal. And basically, you had a ladder, and you had 2 sets of ladders, one for the Schumann and one for the guide scope. People were lined up to use both. And then when you got outside the dome, the sky was full, like dark, full, Pleiades, all the constellations. I mean, it was just like a swarm of stars. It was so dark. Amazing. So, well worth the time and effort to get there, and the small price you pay to attend. So, thanks. Any other questions? Okay, thank you.
Thank you very much, Warren.
On behalf of the RASC Winnipeg, just a little thank you.
Oh, thank you very much.
And so that concludes our meeting for tonight. Just welcome everybody to come over to Boston Pizza afterwards. And just a pitch out there, you saw Mark tonight talk about something he did on his vacation. We're always looking for other speakers. If you're interested in putting on a presentation, either a beginner session or a session main talk, please let Judy know, Judy Anderson,